Here in section 3.2, we are going to start looking at measures of variation. Variation is one major reason life is interesting. If everyone had the same height, weight, eye color, etc., life would be more boring. So since members of the same population still vary in different ways, we can study trends, patterns, and make predictions more accurately once we understand variation. The key measures of variation are range, standard deviation, and variance. We will be taking a look at these three things throughout this section. So let's take a look at an example. We're going to consider the two data sets below. These values are a random sample of one household's utility bill payments for two selected utilities. What can you tell about the utilities if you compare the means? So here we're looking at utility A has a mean of 34.51, while utility B has a mean of 87.63. So just by looking at the means, it looks like that utility B is going to be higher. Which utility appears to me to be more consistent? So if you're looking at more consistent, we're looking at that the values stay closer together. It looks like utility A all is in that $30 range, while utility B goes anywhere from as low as, here's a low of $65.11 up to, I see one for $116.13. So it looks like that utility B has a lot more variance, but utility A is more consistent. Here's a histogram. This does have more data than what you just looked at. So here's a histogram of utility A. Let's take a look at the next slide and we'll see a histogram of utility B. So here we have, again, with more data, the histogram for utility B. So utility A is more consistent, and what did that histogram look like? So it had a more normal distribution. It did have a little bit of a skew to it. It was a little bit left skewed. But isn't it interesting that a more consistent histogram had that spike in the middle of the data? And utility B is more spread out, and the heights of the bars in the histogram are more similar to each other. So consistent must not be referring to the heights of the bars in a histogram. It must be referring to how close the data values are to each other. So again, your more consistent is looking at just the data. It's not looking at the histogram. The histogram will look more normal. We can measure and compare a data set's variation by using one of the several values: range, standard deviation, and variance. The range for a data set is the difference between the maximum and the minimum. So our formula here is going to be range equals the max value minus the min value. Since range is calculating only using the two most extreme values, it is highly affected by outliers. There is no Excel code for the range, but you can sort the data and then subtract it manually, or you can type in the code equals max and then select the data, minus min and select the data, and Excel will then know to pick your max value and then pick your min value. So we're going to look here at variance and standard deviation. By definition, a data set standard deviation is the square root of its variance. So that means this formula, you're going to see that standard deviation equals the square root of variance. And that means that the variance is the square of the standard deviation. So variance equals the standard deviation squared. So let's learn some more symbols. Here is some notation that we will be using throughout the semester. Sigma is the population standard deviation. Sigma squared is the population variance. while S is the sample standard deviation, and S squared is going to be sample variance. If you are trying to type symbols in Word or in Blackboard, there are some short alt codes. You can see those all listed here. We may or may not use them for these, but just in case you need to type something for me, I want to make sure you guys have those codes. So population versus sample. When we discussed means, we mentioned that we have a mu and a capital X bar have the same formula, even though one is used to label a population mean and the other is for a sample mean. For variance and standard deviation, we will use different symbols and have different formulas depending on whether it is from a population or a sample. So we first want to look at identifying whether the following are populations or are samples, and you're going to look at those keywords as well. So just take a couple minutes. You can pause the video here and do those 3 examples. You're going to have to remember back to that chapter 1 of sample versus population, and then you can come back and restart the video and see the answers. So after you've done this, you should see that first one, the following table gives the rental price for 24 randomly selected office spaces in Miami in dollars per square foot. So we have 24 randomly selected office spaces. So that would be a sample. And our next one, a random sample of 50 students were asked to report the number of hours they spend studying each week. The following list is their responses. So we have a random sample of 50 students. So this is a sample. The salaries of 21 employees at a local restaurant are given to below. So here we have the salaries of 21 employees at that restaurant. So because it's given all 21 employees of that restaurant, it is a population. Here are the algebraic formulas for population, variance, standard deviation, and sample variance and standard deviation. We will not be using these, okay? We are going to be using Excel formulas. So here are our Excel formulas that we will be using. So I want to make sure everyone is just very careful with when you're using it for a population versus a sample. So here are our populations. So we've got population variance. You're going to use equals var.p and then select the data. For population standard deviation, you're going to do equals stdev.p and select the data. When you are working with your sample, you will use var.s and select the data, or for a standard deviation, you'll use stdev.s and then select the data. So please be careful when you are using these Excel formulas. So standard deviation and variance. If you are asked to find a standard deviation, the first thing you need to do is determine if the data set is from a population or a sample. And then you're going to just type the data into Excel. Remember, if it's a sample data, you'll use equals stdev.s in the data. If it is a population data set, you'll use stdev.p and select the data. When you're asked to find the variance, again, first determine if the data set is from a population or a sample, and then you're going to use your formulas depending on which one it is. If it is a sample, you'll use equals var.s and select the data, and if it is a population, you'll use var equals p and select the data. So here we're going to look at some important properties of standard deviation. The standard deviation is a measure of how much data values deviate away from the mean. The value of standard deviation is never negative. So S is never negative. It is 0 only when all of the data values are exactly the same. Larger values of a standard deviation indicate greater amounts of variation. The standard deviation S can increase dramatically with one or more outliers. The units of the standard deviation S, such as minutes, feet, and pounds, are the same as the units of the original data values. And the best sample standard deviation S is a biased estimator of the population standard deviation sigma, which means that the values of the sample standard deviation S do not center around the value of sigma. Here we're going to look at just significant values, and we will be using significant values throughout the rest of this semester. So significantly low, or if you hear something like unusually low, values are going to be 2 standard deviations below the mean. So that's why you're seeing this mean minus 2 standard deviations or lower. So significantly low values are going to be down here. And significantly high values are going to be 2 standard deviations above the mean. So that's going to be these values that are up here. Your values that are not significant or not unusual, so these are going to be your usual values, are going to fall in between the 2 standard deviations below and above. So these are the usual values. So after looking at significance, we're going to take a look at the empirical rule for data with a bell-shaped distribution. So the empirical rule states that for data that have a distribution that is approximately bell-shaped or normal, a normal distribution, the following properties apply. About 68% of all values fall within 1 standard deviation of the mean, about 95% of all values fall within 2 standard deviations of the mean, and about 99.7% of all values fall within 3 standard deviations of the mean. Now, these percentages are rough estimates, so this rule should be seen as a general rule of thumb, not as exact values. The percentages on the following slide are also rough estimates. Even though they may have more digits, keep in mind they are all approximations. So here you can see this empirical rule broken down. We have our mean. Remember, the mean is here in the middle. And now we're talking about when we are saying 1 standard deviation, 2 standard deviations away, 3 standard deviations away, you're looking at these movements. So like this first one is 1 standard deviation away. So we're saying that 68% of data falls within this area. Okay, and then if we go out 1 more standard deviation, so within 2 standard deviations, we're saying that 95% of data falls within this area. And then if we go out 3 standard deviations, we're saying that 99.7% of data falls within that area. So here's what you're going to see. All of this would be approximately 99.7% of data. Now you see these numbers that are also broken down in here, like 34.13 on each side. Well, how did you get to that number? Well, if within 1 standard deviation is 68%, then 68% divided by 2 gives me 34%. And that is why you're seeing those values there. Because things you have to remember about those normal curves, right? It is a symmetrical curve. So I can take that number and then cut it in half. So how do we get to that next value? Well, if it is 95% within 2 standard deviations, okay, so I'm looking at how am I getting this value, then I'm going to do 95% minus the 68% that's within 1 standard deviation, okay, and then you're going to divide that by 2. So what you should have is 27% divided by 2, and that gives you 13.5%. Again, the picture you're actually seeing is giving you more decimal places than what I am showing you here. And then you would do the same thing to get that little 2.14%. If you notice, there is a very, very small percentage out here on these tails. Only about 0.13% of data falls in those little tail areas for, again, a normal distribution. So we're going to look at an example using the empirical rule and questions that you may have for that. So here we have the IQ scores are bell-shaped with a mean of 100 and a standard deviation of 15. what percentage of IQ scores are going to be between 70 and 130, what scores are going to be between 70 and 100, what percentage of IQ scores are higher than 145, and then what percentage are lower than 115. I am on the next slide going to fill out all these pieces for you, and then we'll go back through and answer those questions. So here I have an empirical rule, and I'm going to start with what I know. So the problem told us that we have a mean of 100 and a standard deviation of 15. So I'm going to go ahead and start with, well, my mean of 100 has to go in the middle. And then I'm going to fill in those pieces for my standard deviations below and above. So if I'm moving to one standard deviation below, I should do 100 minus 15 to give me that 85. And then you're going to do another subtraction of 15, or what you've been seeing is something like 100 minus 2 times the standard deviation. Okay, and that's going to give you 70, and then we're going to do 100 minus 3 standard deviations, so 3 times 15, and this is going to give you 55. And then to go above the mean, you're going to be adding, so you'll do 100 plus the 1 standard deviation, 100 plus 2 standard deviations, and then of course 100 plus 3 standard deviations. So those numbers are going to be 115, 130, and 145. So now that I have my values put on my normal curve, I am going to start to answer those questions. So I'm going to go ahead, let's erase this bottom part so we have some room here. And our first question asked us that what percentage of IQ scores are between 70 and 130. So between 70 and 130. So we're looking here. Well, if this is our X bar and this is 2 standard deviations below and this is 2 standard deviations above, so within 2 standard deviations, that is, if you remember back to the rules that I told you, about 95%. So your first answer should be 95%. So about 95%. Now, if you add up your numbers here that are given to you in this chart, I think you're going to get 95.44%. Again, this 95% is an approximation because that's how it is with an empirical rule. Question 2. What percentage of IQ scores are between 70 and 100? So now we're just looking at this one part between 70 and 100. So you can add up your 13.5 plus 34, and you should get 47.5%. Okay, if you use the exact values given, you get 47.72%. Looking at number 4, it says what percentage of IQ scores are higher than 145? You can see above 145, that's this 0.13%. And what percentage of IQ scores are lower than 115? So we're going to look at below 115. That's going to be all of these values. And if you add up all of those for number 4, you should get 84.12%. So I'm going to let you guys try an example on the Ebola incubation period. We have the Ebola virus incubation period is bell-shaped with a mean of 12.7 days and a standard deviation of 4.3 days. I want you to draw a bell curve and label the horizontal axis, and then you're going to figure out what percentage of infection will be and will have an incubation period between. And you can see here in number 1, 2, 3, we have between 12.7 and 17 days, longer than 17 days, shorter than 4.1 days. And then number 4, if 400 people infected, how many do you expect to have an incubation period between 4.1 and 17 days? If you're following along in the PowerPoint, the next slide has a place for you to fill out a normal curve and answer the questions. You can go ahead and do that, pause the video here, and then when I move to the next slide, you will see the answers. Here are the answers for this example that you guys just worked. And if you have any questions, please go to Microsoft Teams, our class channel, and I have a Unit 1 questions folder there.